Okay, hi, I'm Georgia. And the title of my paper is Global Ocean Conveyor Lowers Extinction Risk in the Deep Sea. So, to introduce this paper, we know that the species extinction risks are rising because of human activities, and the global habitat is losing, and the rapid climate change is threatening our Earth with the sixth mass extinction. So we look into the past records that shows the species geographic range and habitat breadth that are reliable for the predictors of our extinction risk. We be using the fossilized remains of marine calcifiers, particularly reef frameworking forming cold water corals. And the paper chose Laphilia pertusa because it is globally distributed deep sea coral and it creates biologically diverse habitats, and they are widely spread across Atlantic Ocean. And its skeleton allows for precise dating of fossils and the capacity for wide larval dispersal. And there are some glacial-interglacial cycles of recovery documented for Laphilia to understand its historical responses to changes in the climate and oceanographic conditions. And they are suggesting for potential of their recovery. And we will be talking about this a lot. This is Atlantic meridional overturning circulation, which is a system works in the Atlantic Ocean. It redistributes warm saline water masses northward along Charlene density surface, and it facilitates southerly circulation of cooler, fresher water at deeper levels. And it is a crucial component for the global ocean conveyor belt system. And it has direct consequences for marine ecosystems, such as it alter the ocean productivity. And it also acts as the mechanism for dispersing larvae across large distance, and it creates broad-scale ecological connectivity. And our purpose is to uncover the relationship between ocean circulation patterns and ecological resilience. And here's the methods we be using for the fossil coral chronology using sediments, coring expeditions, and a lot of uranium, thorium series. And they are radiocarbon ages for fossil Laphilia under 25,000 years ago from across Atlantic Ocean and Mediterranean Sea. And for fossil history and Atlantic over AMOC strength using deep water records of sedimentary, and they are some core sediments from many sites. And the dispersal pathway and the paleocirculation, they are the orthogenic and neodymium for this AAIW Atlantic Intermediate Water we be talking about for the next past slides, and the isotopic compositions and coral biography and genetics using the migrate to estimate its coral migration rates. So come to the results. Coral recovery and AMOC spin up. So here is a figure. For the x-axis is the age, which is the time, and the y-axis is the latitude. And we see that the axis at the right, which indicates strong or weak AMOC, the Atlantic meridional overturning circulation, and the LGM is the last glacial maximum, and the HS1 is Heinrich Stadial 1 and the Younger Dryas. And the blue bar indicates the Laphilia occurrences, which means that there is Laphilia there. So here we see that Laphilia remain rare because of during this period is the glacial period. They have increased melt water pulse and slow down in both deep and intermediate water mass layers of the AMOC. So it actually caused unfavorable environmental conditions for them to survive. And here is the spin up. Here is a substantial increase in the AMOC strength following the younger Dryas, which is a crucial phase in species recovery because it got stronger. And at this point, the coral achieved an re-expansion, colonizing over 7,500 kilometers away in 400 years. And the second one is we're about to see the pathway to recovery in the Western Atlantic. Here is another huge map, and we see the orange line goes from south to north is the Atlantic intermediate water, and there's a lot of red circles is the distribution of Lophilia today, and in the middle, from Florida to North Europe, here is the GS, means Gulf Stream, and the North Atlantic currents. And the yellow line at the right of the two circle is the Mediterranean outflow water, the yellow line. And the upper circle is the subpolar gyre, and the lower one is subtropical gyre. And this here there is some Lophilia occurrences at Brazil. They thrive during the last glacial maximum and persisted throughout the most HS1 and younger Dryas. But the glacial refuge in Brazil supports the population during this slower overturning. You can see that the line goes down, indicates weak AMOC. And the paper also tells us that Antarctic intermediate water is likely to help them distribute the coral larvae along Brazil's shores. So it gives them to some growth. And here is another figure of the relationship between Antarctic intermediate water and the northern component water. And here is a line goes rapidly up. This indicates the Straits of Florida suggest modern Antarctic intermediate water pathways and entrainment into the Gulf Stream. And in addition to renewing the upper limb of AMOC, modern Antarctic intermediate water pathways may have helped establish the flourishing Lophilia reef present today in the Gulf Stream, because the water goes off Brazil to the Straits of Florida. And here, the early Holocene shift, because of the glacial is over, and to oceanographic region dominated southern ocean water masses off Brazil and facilitate the transferred Antarctic intermediate water into the Straits of Florida and Gulf Stream. And the coral larvae might have been reintroduced to Gulf Stream, contributing to the formation coral reef we see today. And this whole part is the Western Atlantic. Modern coral distribution pattern shows a strong connection between them, and indicating there is some larval exchange. And this re-establishing ecological connection between Brazil and Florida along with the Antarctic intermediate water. And the paper also tells us that the Gulf Stream may not facilitate ecological connectivity to the northeastern Europe, because this person discovered that most larvae from the Caribbean and Gulf of Mexico stay within their local areas and they cannot disperse across Atlantic. And this subpolar gyre could achieve transatlantic connectivity in the deep sea. And the third one, pathway to recover in the northeastern Atlantic. Here is another map. And here, the North Atlantic currents transport a mixed water from different sources into the circle part. And the changes in the subpolar gyre states influence its pathway and properties, impacting its flow direction. When it's strong, it shifts the flow path directing to the Norway instead of Iceland. And the shift, along with a stronger subpolar gyre during the early Holocene, facilitate the rapid transport for coral larvae across the northern Europe. And here's another figure. The green stars tell us that corals from Mediterranean, the glacial refuge, were exported to northern Europe with the enhanced Mediterranean outflow water. And Lophilia population in northeast Atlantic, they have high connectivity, allowing the import from southern Europe from the Mediterranean outflow water. And new estimates of coral migration rates also confirm the historical and ongoing importance of the Mediterranean Lophilia populations that of Northern Europe. So come to the conclusion that the fluctuation in strength of AMOC can profoundly impact the resilience of...
Okay, 12 minutes, stop.
Okay.
Hello. Okay, I just wonder the chart in page 18. Because I don't really understand what is this graph means. So can you explain it again?
This figure is actually the same as this kind of paper we are seeing because it explains the relationship between Brazil, and for this part we are talking about the Western Atlantic pathway to recovery. So this is the relationship between Brazil and Florida, and the relationship between the Antarctic intermediate water and NC, the northern component water.
Okay, I want to know why you just choose this paper to, yes.
Because of human activities are destroying our planet, and the sixth mass extinction are threatening the Earth. So this is very urgent.
I want to ask about the mechanism of the lava dispersal. You mentioned that it will cause the big scale biological connection, and what does it mean?
Because of the global ocean conveyor, they carry the larvae across the Atlantic.
I want to ask how much time you do this work and include read the paper and make the PPT, because your word in PPT is a little hard. So I can read it very immediately.
Hard. Oh, I make it too hard. Because of this paper, it is also hard for me. So this is the best I can represent to you guys.
And what the first question you don't answer me?
How many times? 7
Yes.
days.
Okay, 7 days.
Hi, I want to ask, is there only one species of coral level focus? This paper only focus on one species?
No, it's Lophilia, but they are, I think the paper tells us that this kind of larval, but maybe not Lophilia pertusa, like Lophilia, other species.
Oh, okay.
So I think Georgia, she selected a very difficult paper, but this is her choice. So you have to take the consequence. And from what I've seen, the flow of logic is not very clear. And part of the reason is because the paper is super difficult, containing a lot of jargon from paleoceanography. So as I mentioned in my very first talk, if your paper involves paleoceanography, it's usually a disaster. And so now, first, I think a major problem of this talk is for this kind of graph, I think in this graph, she tried to explain it. I don't know how many of you know this, and how many, I don't know, because you're a Department of Oceanography, not geoscience. So I suppose that not all of you understand paleoceanography. So I don't know how many of you know what happened to the Earth during LGN, HS1, and YD, because later on she started to talk about something like a meltwater or something. And does that make a sense to you that why meltwater should occur during this and that period? So that's usually a problem for paleoceanographic presentation. That is, you need to provide enough background information for the audience to understand what you are really talking about. That's the first thing. So there isn't enough information regarding what really happened to the Earth. And then the second is, at some point, she tried to, because in this talk, the talk involves a lot of ocean currents. So at some point, I started to get really confused, which is what. And these are the ocean currents discussed in this paper. So there are a lot of currents. And at some point, she started to split the whole story into different areas. Like I think, using this slide, she talked about the dispersal from South Atlantic Ocean to the North Atlantic Ocean, which is good. However, there are two weaknesses. The first thing is, it is unclear to the audience how this conclusion was reached from the data. Because the data is difficult to understand, even to me. Okay, so look at this. What's that? Okay, I really have no idea what's that, even though I'm a geochemist. Okay, so I always need someone to remind me a higher value of this means what and lower value means what. However, this was missing in this talk, and I suppose that this kind of graph, because this graph comes before the interpretation here, so I suppose that there is a cause and effect relationship between the graph and the map, the story she wants to tell here. But I don't see the connection, so there's a missing flow of logic here. And this also applies later to other area where later she talks about the dispersal maybe from here to here or maybe in the Europe. But she couldn't make the logical link between data and interpretation. This left her talk looks like a little bit like storytelling without scientific evidence. And another thing is this is very difficult to understand. Okay, so I don't know if you have tried the tip I have instructed you that several weeks ago. I show you how to simplify your text using ChatGPT to make yourself more understandable. You have to prompt your GPTs, like you have to explain this to kids, for example. Then maybe the ChatGPT will offer you some more simpler phrase for you to present to the class. Otherwise, this is really literary and very difficult to understand. Okay. Then, therefore, I think these are the major weaknesses. Therefore, if this talk for the second time, you have to try to build a logical relationship, starting from explaining the graph clearly and providing sufficient paleoceanographic background information, like what happened during this period and what these parameters mean, and then what happened to the corresponding current, and at the end, what happened to the larva of the coral. You have to build this logical link. And in that case, considering you already use more than 12 minutes, I suggest that you condense your story. You don't need to present them all. Maybe you focus on the western side of the Atlantic and the eastern side of the Atlantic. You don't need to talk about this transatlantic dispersal. Just this part and this part. Okay, so thank you, Georgia.